Okay, great. So I'm presenting on behalf of a much larger team with Principal Investigator Phil Townsend, and most of the people there as team members are based out of JPL. However, we also have Justin Mers from UC Davis. This is the imaging spectroscopy processing environment on the cloud, formerly called ImgSPEC, but has been rebranded to the ImgSPEC, big reveal here at SO Forum. Main reason being that ImgSPEC domains were all gone. So think about that when you write a proposal. Next slide. So what we're trying to do with ImgSPEC is essentially have an eye to the future, and that's that in 2017 the Decadal Survey prioritized a global spaceborne imaging spectrometer. This is very large data volumes, about 20 terabytes of data per day. We see that now with SWOT and with NISAR, but what makes imaging spectroscopy data different is that it's also highly dimensional. So this means that we can actually derive information products. Right now, our current analysis has, I think, over 230 algorithms for processing this data, resulting in about 125 discrete different data products. There's no way that any single NASA mission could produce all that. And so the idea behind ImgSPEC is really to break down these barriers so that we can enable scientific investigations with the information that resides in that data by removing the barrier to producing products of value for those scientific investigations. So next slide. Basically, what we want to do is we want to help with data dissemination for this future surface biology and geology global imaging spectrometer mission. And we want to do this by creating a usable work environment where scientists who come up with information, scientists and data scientists who come up with information products from the raw data would be able to exploit the same kind of services that we provide in a current NASA science data system. So that includes things like provenance and metadata standards for reproducibility. And so kind of like Google Earth Engine allows different scientists to be able to, access all of the data in one hub and then also be able to write their own algorithms to produce a product. We would have something very similar in ImgSPEC, but we would also provide things like workflow management and deployment for producing products more globally, as well as metadata and tracking for provenance. So the main objective of our work is to demonstrate an end-to-end on-demand processing platform on the cloud, specifically focusing on imaging spectroscopy, level 1 through level 3 information. Next slide. So ImgSPEC is a user-centered design, and it prioritizes functionality based on interviews with sister AIST biodiversity projects. So we recognize that we're sort of focused on biodiversity, especially in terrestrial ecosystems, but that we can cater to a much larger community, but we had to start somewhere, and we started there. But generally, we think of these users as breaking them up into remote sensing algorithm developers and researchers who are interested in statistical analyses or models. The first 4 little bubbles there in the user interface are pretty standard. You see those in most sort of data portals that you see: search for available data, display geospatial data products, download and extract point values, maybe compare some statistics, maybe there's some on-demand analytics. The place where ImgSPEC really gets unique is in that 5th bubble, which is select a standard or custom processing workflow. And so this is really where we're trying to say, NASA typically provides the 80% solution when providing a global data product that works over 80% of the globe, but maybe not in your area. And you might want to customize that to work better in your specific area. Or maybe you're specifically focused on wetlands and your product, and the global product just doesn't account for wetlands. And so we want to be able to provide that flexibility. And so that's where we sort of enter into an algorithm development environment. A standard workflow would have config parameters and run through a normal product pipeline, just like we would normally have. But a custom workflow would allow you to customize individual steps from that process by pulling from something called the algorithm store. People would be able to load data, to load their own data to refine their algorithms and also save them. Next slide. So these are the technical details here. I really rely on our software team for a lot of this. But basically what we're doing is we're integrating 3 standalone technologies to create a sort of dynamic system. So the 3 technologies are MAP, which is, I think, the multi-mission analysis and analytics platform. And this is really a shared collaborative algorithm development environment. And then what we're doing is we're going to build the interface to hybrid SES, which really takes the best of cloud compute, on-demand cloud compute that can scale for both reprocessing and on-prem services and workflow management. And then that data would sit in an Amazon S3 bucket that SDAP could then interface with to have a dynamic data portal that provides people on-the-fly analytics to be able to look at the data products that are being produced. We also interface with other softwares that were developed under previous AISPs. So one of them is EcoSys, which you see in the lower left. That's an open source spectral, a repository of spectral data that people might use as in situ to help refine their algorithms, as well as EcoSML, which is a repository of different models and code that people have been developing specifically for terrestrial ecosystems, which we then build an interface to our algorithm store so that we can have sort of, quote, blessed or approved algorithms that we say, okay, look, we've actually vetted this algorithm. You're welcome to use any others, but these are the ones we approve. Next slide. So our next steps is that basically where we're at right now, we started in January, is we conducted a user needs assessment, and we really used that to define our project functional requirements. We're beginning to define the interfaces and containerize our PGEs. We've set up our Amazon environment, and our first system test with default workflows is scheduled for the end of this fiscal year. And we also have a publication that is in review right now at Harvard Business Review for the particular approach of user-centered design around software engineering requirements. So I think that's it. I thought of that on time.